Section 15.2 is on concentration of solutions. What I'd like you to do is just jot down the notes. If you need to pause the video at any point to get the terms down, that would be fine. We're going to get through the term part first, and then we'll talk about the math tomorrow. So 15.2, concentration of solutions. First question is, what is the difference between a solution that would be considered concentrated versus diluted? So try and come up with an example of something you think is dilute and something you think is concentrated. These are the definitions that we have for concentrated and dilute. Concentrated is when you have a relatively large amount of solute for the given amount of solvent. And dilute is a relatively small amount of solute for the given amount of solvent. So if I were to ask you, if I have 1 gram of sugar in 100 grams of water, would you say that is dilute or concentrated? The most would say that's not very much, so 1 gram in 100 is dilute. If I said, how about 100 grams of sugar in 100 grams of water, what would that be? And most would say, well, that's concentrated. Well, my question then would be is, how do you know when it goes from dilute to concentrated? And quite often students will say, well, if you are in the middle, if you have 50 grams in 100 grams of water, that must be where it changes. So does that mean 48 grams is dilute and 51 grams is concentrated? The problem with these terms is they're relative. What seems to be a large amount for one and make something concentrated might not be for the other. So we in science like to be a little bit more precise, and that's why we actually have concentration. So the definition of concentration is the amount of solute in a given amount of solvent or solution. So instead of just saying I've got a relatively large amount or small amount, I want to know the exact amount. The exact amount of solute dissolved in a given amount of solvent or solution. We've got 2 different definitions of or equations for concentration we're going to give you today, and a third one tomorrow. But here's the 2 ways to measure concentration we have today. Molarity, with a capital M, is the number of moles of solute dissolved in each liter of solution. If you write that as an equation, big M is moles over liters, and make sure you know it's liters of solution. That's something you need to learn. Got to memorize. Molality, which is going to be a lowercase m, is the number of moles of solute in each kilogram of solvent. So it's still moles, but now we're dividing by kilograms of solvent. So they're similar. They're both talking about an amount of moles, but they're different in what you divide it in. Molarity is a liters per solution, moles per liter. Molality is moles per kilogram of solvent. Let's look at how the solutions are formed and see what the difference is here. Here's the first equation, molarity, number of moles of solute dissolved in each liter of solution. So if I would go to my scale, look up the molar mass of some compound, weigh it out on a scale, let's assume I have exactly 1 mole of the substance right here. And I want to make something whose molarity is 1 molar, which means if molarity is 1 molar, I need 1 mole in 1 liter. If we measure out the mole, and then we measure out exactly 1 liter of water, if I pour those into that flask, what happens to the volume of the solution? Well, when that powder goes in, hopefully you realize that the liquid level would actually rise, and now we no longer have 1 liter of solution. I've got a little bit more than that. So when you're making a solution, for molarity, you cannot just measure out 1 liter of water. 1 mole and form together. What you need to do is measure out 1 mole of the substance, put that into an empty flask, and then add water until you get up to the 1 liter mark. That way you're ensuring that you only have 1 liter of the whole solution, the solute and the solvent combined. Whereas, if you look at the equation for molality, that's the number of moles dissolved in each kilogram of solvent. Well, if I want the molality to be 1, I need 1 mole in 1 kilogram of solvent. I can easily measure out 1 mole on the scale. I can easily measure out 1 kilogram of solvent, which if it's water, we know is 1 liter. And then you just pour those together, and yes, the amount will go up, but we don't care because we need 1 mole of solute and 1 kilogram of solvent. It says nothing about how much the total solution will be when we're done. So it seems like a minor technicality, but the equation causes us to make sure we add the stuff the right way. With molarity, put it in first and then add water or solvent until you get to the proper amount of solution. With molality, measure out the amount of solvent you need, the amount of solute you need, and just pour them together. We'll do some math with this tomorrow.